This is the solution video for question 3 from section A of the 4th sample test for CSAT. In this question, we're told A is an integer that is greater than 1. And we're asked to find a non-integral expression in terms of A for f of A equal to the integral between 1 and A minus 1. It's called floor of x times floor of x to the minus 1 with respect to x. So what is floor of x, this function? That is the function that sends a number x to the greatest integer less than or equal to x. So for instance, the floor of 3.5 would be 3, the floor of 6.2 would be 6 because that's the greatest integer less than it, and the floor of 7 will be 7 because it's less than or equal to, and 7 itself is an integer. We don't know any hard and fast rule to actually integrate this with respect to x. We don't know how to generally integrate for floor functions or things that look like this. So one very useful thing to do would be to sketch a graph of this function and see what's going on. So here's some axes, 1, 2, 3, 4 on the x-axis. And the good thing is we're not going to actually have to do that much work to work out what's going on in this function, because it only changes behaviour or changes value once x passes an integer. Because if we put x is 1.8 in or 1.2 in, the floor of those two numbers is the same. So the function will be constant between integers. So let's have a look when x is between 1 and 2. Well, we get minus 1 to the 1, so minus 1, times by 1 to the minus 1, which is 1. So we just get minus 1. So we know our function looks like this between 1 and 2. Between 2 and 3, well, this is 2, so minus 1 squared is 1, and 2 to the minus 1 is a half, so we get a half. Similarly, if x is between 3 and 4, floor of the number's 3, so we get minus 1 to the 3, which is minus 1, and 3 to the minus 1 is 1 over 3, so we get minus a third, and going on to get a quarter, minus a fifth, etc. So this is what this graph looks like, and now, finding the integral doesn't look too bad, because the integral up to a certain value is just the area of lots of rectangles here, as shaded in green. So we do this minus this area, plus this area, minus this area, plus this area, etc. So we can convince ourselves, because the width is 1 and we know this is height 1, a half, a third, a quarter, etc., that we need to do minus 1 plus a half, minus a third, plus a quarter, all the way up to adding or taking away 1 over a minus 1 when we're finished. Because we know we stop at the integer a, and if we look at 2, we're doing 1 over 1, 3, we're doing 1 over 2, so at a, we're doing 1 over a minus 1. So we can convince ourselves pictorially that this is the answer. But if you're not happy with that, because you might not be convinced by the picture, and there might be a bit of confusion whether this is 1 over a or 1 over a minus 1, etc., we can do it algebraically as well, inspired by this picture. So we've got to find f of a integral 1 to a minus 1 to floor of x minus 1 with respect to x. So what we see from this picture is the behaviour of the function between whole numbers is really nice. So let's split this up. So instead of integrating from 1 to a all in one go, I'm going to integrate from 1 to 2, and then 2 to 3, and then 3 to 4, all the way up to a minus 1 to a. So how does this help? Well, we know x between n and n plus 1 is just n, floor of x, and floor of x again is n. So we can just replace all the x's, floors of x's, by n's, and now we're integrating a constant along an interval of size 1, so we just get the constant. So we get sum of minus 1 to the n over n, n equals 1 to a minus 1, and so this matches this, which is very reassuring. And so either by a bit of intuition or very rigorously with integral and with splitting up the area we're integrating over, we have derived what f of a should be in a non-integral expression.